Yeah, I think it's great what you're all doing here and bringing kind of mathematical ideas. I think one of the most exciting things I saw when I made that Secret U was going to Giulio Tononi's lab and trying to fall asleep and failing. So they had to show somebody else's results, not mine, having some stimulation on my brain. But yeah, it was a very exciting journey. I think it's a very exciting time for consciousness. I'm a mathematician here in the maths department. My area of expertise is number theory and group theory, but I suppose the whole of society has been a little bit freaked out by the advances in artificial intelligence at the moment. I mean, we've had kind of like 4 decades of AI winters, and then suddenly we're into this heat wave, and I think a lot of people are just kind of concerned. Well, what is going to be a job in 10 years' time? For our math students here, a lot of them went on to do actuarial work or accountancy. That's not going to be a job in 10 years' time, probably shorter than that. So, but I did always feel that my own job of mathematics was always very safe, partly because I think that, I think most people think actually my job should be the first to go, because, what is AI? It's just algorithms. Algorithms is just maths, and so it's doing maths every time it does something. But actually, I think that a lot of people I talk to who are not mathematicians, I think they think, well, surely you've been put out of a job ages ago. But I think that's because most people think that I'm doing long division to lots of decimal places. That's what fundamental research is. That's what I'm doing in my office upstairs. But actually, I always say, no, actually we do something much more exciting, and it's actually, and I use this word creativity as my kind of protective shield against why I thought that artificial intelligence could never do what I do, because mathematics and science in general is a highly creative, often counterintuitive. Your leaps into the unknown and then you try and connect it up with a proof. But those kind of leaps into the unknown, it require that kind of sense of creativity. And I felt, surely that's something that an AI, a computer, can never do, is be creative. That creativity is something that is unique to being human. But I got a real shock, and I think there was a real phase change for me, and it's one that I think marks perhaps the first example of potentially something you could call computer creativity. And that's in the very famous game of Go that was played against Lee Sedol. DeepMind developed this algorithm that they felt could play this game, 19 by 19 board. Seems very simple. It's just black and white stones put down, pixels, but it's a very complex game, always a game that computer science found it very difficult to write code to play. Partly because, if you ask a Go player how they play, often it is quite intuitive. It's pattern recognition on the board. There's a lot of creativity, perhaps more so than chess, which is about logical implications of the pieces as they're played. But we've had this kind of phase change, and I think it is the fact that, code in the past was written in this very top-down manner. You had to write instructions, which the computer could implement at speed and at depth more than a human could. But somehow the human was still telling the machine what to do. But I think this kind of change of this bottom-up learning process, deep learning, machine learning, has allowed code, and this is the example of AlphaGo is extraordinary, that as it played more games, learnt games, played synthetic games, it got to a level that it could actually beat Lee Sedol. I mean, Lee Sedol initially was very dismissive of this, thought it wouldn't get anywhere near him. But he was very shocked to come out the other side of this match having lost 4 games to 1. And the one game he won, he now regards as the greatest win of his career, to actually beat this bit of machine. And I mean, I suppose we got very used to machines doing things better than humans, playing games, or machines can go faster than us down a racetrack. But I think what was significant for me, and I watched these games live on YouTube when they were being played, partly because I've always used Go actually as a kind of example of what I think mathematics is quite similar to. It is that kind of pattern recognition. You're not quite sure why you're playing a move, and maybe afterwards you'll understand why. And the fact that AI couldn't play Go, I always felt, yeah, Go is like maths. And so as I watched these, I had a kind of existential crisis as this piece of code was doing better and better each game. But I think it was the second game where something significant happened, and what I would perhaps propose as first example of computer creativity. Lee Sedol had played the 36th move of the game, and by that point he was actually exhausted after 2 matches, and he went up to the top of the hotel to have a cigarette break. We humans still need nicotine to kind of stimulate our creative juices. The code sat and thought for a while and then asked the human who was picking up the stones to put on the board. We still can't do this bit of kit. You know, this is a really complex piece of equipment. So there was still a human who was picking the stones up to put them on the board, actually the European champion. And the AlphaGo asked the human to place a black stone 5th row in from the edge. Now, when I was watching these on YouTube, the commentators at this moment all gasped, and there was kind of, oh, what a huge mistake. And they all went, oh, this is great. Lee Sedol will be able to get in now, because this is traditionally early on in a game of Go a very weak move. The competition is kind of like first 4 rows in. Anything deeper is considered quite a weak move. And your Go master would slap your wrists if you made this sort of move. So Lee Sedol came down and saw this, and you could see his shock when he saw that stone there. And he's just like, couldn't understand what a weak move, but he'd already got a lot of respect for this code and like sat and thought for a while, you know, why is it played there? And he couldn't see why, but as the game went on, competition for the territory in the lower right-hand corner began to be the thing that was going to determine the outcome of this game. And quite late on in the game, it turned out that that move, 37, was the one that won AlphaGo this whole swathe of territory and the second match. Now, I would, why do I say this, I think, is a creative act of the code? Well, I actually like this definition by Margaret Bowden of what she regards as what we should regard as being creative. Creativity, I think, is a bit like consciousness. It's quite a hard thing to pin down. Actually, yeah, so I quite like this definition. I was on a committee with Margaret Bowden and Demis, actually, of the Royal Society when we were looking at the impact that machine learning was going to have on society. And Margaret said, she suggested this definition, that you should regard something as creative if it's novel, surprising, and has value. Well, it certainly passed the test of novel. Novel's nice because it's very objective. You know, you can really say this is a new thing. It's these 2 other ones which are very subjective. I mean, surprise, that's an emotional reaction. Something is creative, it's making you look at the world in a new way. Oh, you want to engage the emotions. But you don't want just shock for shock value's sake. You want it to have some way of changing your interaction with the world. That's something creative will have, should have value about how you then continue your way through life. But I think this did pass that test. The surprise is the emotional reaction of the commentators. They were all shocked at this. It sort of made them sit up and think, what is this move about? And then value, of course, in a game, you can very cleanly judge value. It won AlphaGo that game. Now, I regard this as the creativity of the code because, you know, the machine learning process meant that code became more and more complex as it played games, synthetic games. The code became so complex that, you know, you're unable to understand why it was making certain moves. But certainly if a human had seen that line of code played that deep in early on in the game, they would have deleted that line of code. They would have said, no, that's bad learning. Let's delete that. That line of code, I think, genuinely emerged out of the learning process and interaction with games and synthetic games, and therefore emerge out of that learning process of the code and deserves to be called the creativity of the code and not the original coders who wrote the code. And it's really had a big impact on the way that people play Go. I mean, Lee Sedol and his contemporaries thought they'd found the superior way to play the game. There'd been 2 revolutions in the game of Go previously, one in the 16th century, one in the early 20th century, different ways of playing the game. This AI has now caused a 3rd revolution in the way that Go is being played, and really kind of pushed us off our local maximum, thinking, yeah, we know how to play this game, and revealed that there was actually a superior way. And this has now changed the way we play the game. And I think this, for me, is the most exciting role that artificial intelligence might play. I think we call this talk AI friend or foe. My feeling is that it has the potential to be a great partner in anything that you're doing creatively, because it can kind of push you off your local sense of satisfaction and local maximum and find a perhaps well, not necessarily global maximum, who knows, but a better local, higher local maximum. This story of the game of Go really started me on a journey which resulted in this book that I published a few years ago called The Creativity Code, just looking at, okay, Go is a very nice, tight, clean environment, but what about a messy environment of being human and our creativity? Could AI have an impact on that? And over the last few years, we've seen extraordinary role that AI has played in making things, visuals, music, ChatGPT. So I thought I'd just do a little sort of see how good AI has been at each of these things that we regard as part of our human creativity. Actually, we're not the first to think about AI being creative, and in fact, the first person who wrote computer code already started to think about the idea that a machine might do something more interesting than long division to lots of decimal places. And we celebrate Ada Lovelace as the first computer coder. Lovelace Day each October. She was inspired when her mother took her along to see the Victorian inventions of the day, including Babbage's analytic engine. And she was very excited by this thing which Babbage had just created to do computation, but Ada Lovelace started thinking, well, the engine might compose elaborate scientific pieces of music of any degree of complexity or extent. So she was already thinking of the machine doing more interesting things than just computation. But she had a word of warning to anybody when she wrote the notes about what the machine might do, about how much we should call the machine being a composer, for example. And she said it's desirable to guard against the possibility of exaggerated ideas that might arise to the powers of the analytic engine. There's no pretensions whatever to originate anything. It does whatever we order it to perform. So I think that's been the thought in the past, that this top-down coding, we might tell a machine to do something, it might implement it at speed and in depth, but any music that comes out of that is our creation, not the machine's. The machine has just helped to, when I play an oboe, it's not the oboe that's making the music. It's, well, I suppose it is, but it's not composing the music. But I think that's changed, and I think machine learning is really beginning to challenge Lovelace's idea. And so we now have a challenge, like the Turing test: can a computer pass itself off online as a human, and we can't tell the difference? There's a new thing called the Lovelace test, which I quite like, which is, can a machine originate a creative work of art such that the process is repeatable? I think this is important because a lot of artistic AI computer projects in the past have given an illusion of agency to the machine by introducing some probabilistic or random things, and so we can't explain it, but neither can the machine, and it looks like it's making decisions because we can't explain it. So I like this inclusion of, no, it's got to be repeatable, it's got to be deterministic in a way, it's got to be part of the code, so it's not just a result of hardware error or taking the weather data for the day, and yet the programmer is unable to explain how the algorithm produced its output. I would say the Lovelace test has been passed in the case of the game of Go. I think that is, those qualities have, in a sense, been passed. But what about in the kind of more visual, more artistic, human creative realm? Well, I'm going to start with the visual, because that is actually where machine learning, of course, has been incredibly successful. When I made that program about artificial intelligence at Horizon, it was before all of this revolution kind of happened. I mean, it's not like machine learning is a new thing. We've had the idea for ages. It's just the fact that we've suddenly got data for it to learn on, which has been the big change. But I remember at that time, a lot of people saying, computer vision is the big challenge. That's one of the big hurdles. Computers just can't recognize what's in an image. And that, of course, changed once we gave it images to learn from and data. So if it can recognize images, how good is it at making images? Well, every artist has to start by learning from the art of the past. And of course, that's what machine learning does. It takes data, our data, and tries to do something new with it. But every artist, Picasso learnt to paint in particular styles before he went on to break those styles and do something new. So I think it's only fair that AI should start by trying to see, how good is it at doing art of the past. And so here's a little challenge for you. You can probably recognize the artist behind this. Who's the artist? Rembrandt, exactly. But which one is the real Rembrandt? You see, so there are a lot of Rembrandt portraits, and so that's quite a lot of data. But one of these is by an artificial intelligence, and one of these is actually by Rembrandt. We'll do a little show of hands. Who thinks this one is by artificial intelligence? Okay, there's, yeah. Who thinks this one is artificial intelligence? About the same. Who hasn't got a clue because they all look pretty convincing? Yeah, so it's about a third. So the AI has done pretty well. Okay, who thought this one was the AI? Yeah, why did you think this one is AI?
Theory of mind on your behalf, so I think
theory of mind. Oh gosh, yes, yeah, you're all theory. Yeah, let's do. Okay, right. Theory of mind. Why?
I think
Yes, you're thinking. You think.
Very atypical for Rembrandt.
It's a kind of who thinks this one is artificial and why? Yes. Why do you think this is artificial?
There's a slight asymmetry between the left and right eyes.
Ooh.
See a bit more white in the eye.
Oh, we got a real art critic over here. It's like, yeah. Well, I'll give it. This one is the artificial one. Yeah. And you're right, this one is very unrepresentative of Rembrandt, which I had to do because if I took a representative one, you'll all know it was Rembrandt. So it's actually a rather shit Rembrandt because I had to find one you didn't know about. So, is there? That's very interesting. So you think it was actually, it's not generating anything new. You think it's kind of too much mimicry. I think this is pretty good. It's almost too photographic. It's too good, exactly. It's the photographic quality, I think, almost, for me, would like, it's just almost, some would say it just doesn't give you the Rembrandt shudder. You know, there's no soul in it. But I think the one person who felt they could tell was they brought a Rembrandt expert in. They even 3D printed this. So they learned about the texture of the paint that was put on the canvas. And the expert came in and said, oh, the texture of the paint on the canvas is 20 years later than the actual style of those. It's like they were quite pleased, the AI people, if that's the only thing that they could criticize it for. But many people felt this was, really grotesque project. We've got Rembrandts, we don't need more. I'm a big fan of Jonathan Jones, who's the art editor in The Guardian, who hates anything to do with AI. And he wrote, what a horrible, tasteless and insensitive, soulless travesty of all that is creative in human nature when technology is used for things it should never be used for. But I don't trust an art critic that wears a shirt like that, frankly. But I think actually, it has a point. But this isn't creativity. It's just kind of mimicry. It's pastiche. It's not really making anything new. But that's where we all have to start. That's where Picasso started. So how about breaking into the new? So here's another challenge for you. 4 of these paintings are by humans. 4 of these paintings are by artificial intelligence. Again, let's take a little vote. Who thinks these ones are the artificial ones? Put your hand up if you think the ones on the right are artificial. Okay, who thinks the ones on the left are artificial? About equal. And who thinks, I haven't got a clue, they all look rubbish? No, no, I actually quite like them. Okay, so you're again pretty undecided. I'm intrigued actually because I think as time has gone on, when I've challenged people with this, they're more getting it right that these are the artificial ones. Because there's a certain style that's was beginning to emerge as artificial intelligence tried to make its own paintings, which was this kind of a mix of complexity and vagueness. It's almost a style. And the way these were made, I think, is really interesting because they use a generative adversarial network. A generative adversarial network is 2 algorithms kind of working in competition against each other. So one algorithm learns all of the styles of the past. It takes all of the artistic data for the last 1,500 years or whatever, 2,000 years, learns style. It almost becomes an art historian because if you give it a painting, it'll say that's a pointillist painting or a cubist painting. And then it's tasked with breaking that style. So that's the algorithm has to make something which doesn't fit style. So it has to, it's got its parameter space and it's got to find something which is off that parameter space. But the discriminator algorithms then says, no, that's too close, I recognize that. Or you've gone too far and you're outside of the zone and we don't call that art. So, all of the art of the past represents a kind of boundary set. We want something that we're going to recognize as art, but which is new. So I like the idea of the GAN, which is this kind of to and fro gaming process, which actually did produce I think, images which were interestingly new. I mean, whether you like them or not is a different question. These were both shown at Basel Art Fair in an exhibition, and nobody was told that there was any AI involved at all, and people were asked for their emotional reaction. And people felt more of an emotional reaction to the AI paintings. And when they were told they were done by AI, they felt very cheated. You know, like, but it's got no soul, no consciousness, it's not expressing anything. But I think that's a real mistake. And I think that's a really important thing is this AI learnt on our emotional world. This is an expression, a new expression of our emotional engagement with the world. So it's not surprising that if it's producing something where it's learnt what we value, it's learnt what engages us emotionally, that's going to produce something, it's probably learnt something to do with that. So, you know, if I tell you a joke and then you all laugh and then I say, well, that's created by AI, that doesn't invalidate the laughter. It just means the AI has learnt very well what we find surprising. So I also think this kind of captures the way I think creativity works in the brain, which is that kind of weird good cop, bad cop feeling. I mean, I actually often work with in pairs as a mathematician, and we kind of play these two roles as creator algorithm, discriminator algorithm. One is kind of bubbling ideas, the other one sort of closes down and says, no, that doesn't work. And I think what's interesting is that there's something called the Wundt curve I discovered, which is you know, creativity is about kind of arousing a positive hedonic value to a piece. So you're trying to push, the GAN is trying to push you into this place where you're feeling, oh, that's really exciting and new, and I'm thrilled by that. But it doesn't want to go too far. So if you push something to too extreme, then you start to have a really negative reaction. I can't engage with this, it's too complex. It's so I think the GAN is trying to find this way of, you know, we want to make something new, something you haven't seen before. I think that's why this is exciting. There's a genuine style, I think, which emerged, which we can call a computer style. And what I find kind of sad, well, actually, let me just say, I think a lot of artists talk about the idea of these two roles of the brain. Paul Klee, already at the very beginning of the productive act, shortly after the initial motion to create, occurs the first counter moment, the initial movement of receptivity. This means the creator controls whatever he has produced so far is good or not. And that's one thing, you know, a lot of art projects in the past just spewed out thousands of images and never judged itself. And that's what I think is an interesting new component, that it's saying, no, I'm only going to select a couple of these. Most of the things are rubbish because it's got this judgment from the data that it's looked at. Here's Paul Valéry, a French poet, takes two to invent anything. The one makes up combinations and the other one chooses. So I like the idea of the GAN, and I think it's sort of fallen out of favor as a tool, which I think is a shame. And actually, we've got, you know, since I wrote this book, you know, we've got things like Midjourney and DALL-E coming out. I think that's a really regressive move of these kind of algorithms, because what they're producing is things that we recognize. The point was that felt too fuzzy, something new. We didn't actually like it. We wanted to go back to images that we would see in a magazine. And so I think that the images that are being created, they're amazing. I mean, I'm not saying it's not an impressive sort of algorithms there, but I think it's actually not so interesting. They're things that we actually could recognize. I mean, I think, you know, I got taken in by this. Didn't you get taken in by this? I didn't really care whether he was wearing Gucci or not. So I sort of like, oh, right, so he's not cool Pope, you know. But, you know, that is but that's a boring image. It really is a boring image. The interesting thing, I think, about Midjourney and DALL-E is actually the mix of creative disciplines, because actually, of course, as an artist, what are you doing? You're writing words. You're writing words which you hope will prompt a visual image. One of the things in the early kind of stage of AI creativity is that AI tended to just get stuck in one particular domain. So if it's making images, it only gets given images. If it's making music, it just learns from music. If it's writing, it's just prose that's given. I like the fact that DALL-E now is a mix of that. It's like okay, I've got to become a poet in a way when I'm doing these, then there's a new job, prompting these things to produce something which is visually interesting. And I think that's the artistry, and it is a kind of new artist emerging, those that can use these things to make something which is visually actually quite interesting. So I think that's something new, and it's something which is we did a music project here in which Kobe played a piece of Bach, hybrid AI Bach piece, and we would ask the audience to kind of guess which bit was Bach, which was AI. But when I did this actually earlier in the Barbican, Mahan Esfahani did this with me, and he said, you've missed out a really important data set. You've used all Bach's keyboard works to train the AI. But there was another really important data set, especially in the piece that you chose to do this hybrid thing, because you chose one of the English suites. And you said, why is it called the English suites? I said, I don't know. And it says, it's because Bach loved the cadences of the English language. And he tried to mimic in the piano playing what the English language sounded like. And that's why he has the French suites and the Italian concerto. Language for him was a really important data set. And we didn't even think about putting in language as a data set to create music. So I think that's sort of going forward. And I think the DALL-E and Midjourney are the first to start to see a kind of blending of data sets, labeling the picture and using the language to access the visuals is quite an interesting new thing. But I think, we're still, there's loads of unmined opportunities in, say, for example, what about music being influenced by, we've already seen composers do that. Xenakis loved the idea of taking a visual and trying to realize it in audio form. So why aren't we doing that with AI yet? I'm sure that will be the next thing. But actually, one of the most interesting visual projects produces visuals which I think are terribly kitsch and not interesting artistically, but actually go to the heart of why I think we create art. This was, you probably remember these, it was called Deep Dream. It was Google's kind of reverse engineering of their vision recognition software. So they said, our vision recognition software is so good, it just, you give it a Christmas tree and presents, it will tell you exactly what's in the picture. But what is it actually seeing? That's kind of the challenge, is can recognize, it can say the thing, but it would be nice to know sort of what it's seeing. So they said, let's reverse the process. So let's give it something which is very fuzzy, like these jellyfish, for example, and ask it to just accentuate anything it sees in the image. Just like when we look in the clouds, we give away our internal world because we say, oh, that looks like a dragon or a snake or a face. We see faces everywhere, of course, because we're hypersensitive to faces. So what is AI hypersensitive to when it's shown clouds in the sky? Well, these jellyfish, this is what emerged after a kind of iterative process of feeding this in. A very psychedelic, not very, I wouldn't have that on my wall, but it sort of reveals, again, faces. Yeah, of course, it's trained on a lot of images of faces, of animals, of machine type things. And so I think this is actually a really interesting project, although visually it's not interesting, because it's actually helping us to understand a little bit about the complexity of that inner world of the code, which it's like you can't tell what I'm thinking by just neuronal activity. It's too specific, and the same with lines of code. So you need kind of more general ways of kind of almost projecting down to lower dimensional set to understand, sort of what's going on. And in this case, Deep Dream revealed some really weird learning that had gone on in the Google recognition software. So, for example, it gave this kind of rather gray background, and it started to see dumbbells emerging in the gray background. But when it drew the dumbbells, it always had arms attached to it, because it had never seen an image of a dumbbell on its own. It was always strong men and women. It thought it was kind of an extension of our anatomy. Like, oh, strong men and women grow these kind of weird things at the end of their... So I think this idea of asking the AI to make something, be creative, actually might help us to understand how the code is working. We can't do it on a line-to-line level. We have to find some way of kind of projecting into a different dimensional space to kind of see what might be the way the code is playing. I think that actually is, in a way, why creativity emerged in the human species. I think that creativity, here's a kind of proposal I make in the book, which is I think that creativity and consciousness emerge at the same time in the human species, because when suddenly this inner world was emerging, this voice, I seem to have a voice in my head, or are you getting this? Are you feeling pain, pleasure like I am? That we needed tools to try and probe, you know, this challenge of the whole problem of consciousness. What's going on inside your mind? You know, are you feeling pleasure? Are you feeling sleepy? When is it going to end? I think our art, in a way, is a great way to probe that. And so I think this project sort of captures, in a way, how we should be using creativity in machines, not to help us make new things. We're really good at that, but actually as a tool for exploring the inner world of the code. And I think, you know, art does not reproduce the visible, it makes things visible. This art of the AI will help us to actually see how the code is working. Marshall McLuhan always said art is a distant early warning system that can always be relied on to tell the old culture what is beginning to happen to it. I'm afraid that's all of us, the old culture. So I think that's one of the roles that is underplayed about AI and creativity, that it could be a great tool for understanding much more deeply how the AI is working. The visual world, I think, has been very successful, the still visual world. What about music, that first challenge of Ada Lovelace's? Could it produce a scientific piece of music of any complexity or extent? There have been some lovely projects. In a way, music is very amenable to AI because music is closest to maths, I would say. It's all about patterns, recognizing patterns. We did this project about Bach. It was very convincing. But I love this story about Bernard Lubat, a jazz composer who trained an AI up to play his style of improvisation. And then they did a sort of call and response concert. Lubat's response was very interesting because he said, well, the system shows me ideas I could have developed, but would have taken me years to actually develop. It's years ahead of me, yet everything it plays is unquestionably me. And I think what was beautiful about that is that Lubat had got very stuck in a particular style of playing, and it was very recognizable, but he had a sound world that was much richer than he realized. And the AI opened doors for him and showed him he didn't have to do anything completely new. He just had to use the material he had in new ways. And I think many creative people, we get very stuck in particular ways of behaving. I know I do that mathematically. I just use the same tricks over and over again and hope they prove a new theorem for me. And I think we have a dreadful susceptibility to actually behave more like machines and not humans, that we just kind of repeat things, especially as you get older, it's just like easier just to do what, do the repeat thing. So I like this idea as a stimulus to actually challenge us, actually still with the material we have, that there might be something new to do with it. I set up a centre at the Royal London College of Music called PRISM, which stands for Practice and Research in Science and Music. And we've been using artificial intelligence a lot to kind of stimulate composers in the centre. And one project I really loved, which is we took a trombonist who was incredibly versatile, and he did amazing things with the trombone, different sounds that he could make. He would bang the trombone, and we collected, he just played for hours all the things that he could do. We then fed it into the artificial intelligence, and the artificial intelligence learnt on that and came up with new trombone sounds. Now, some of them were impossible to make because, that's one of the differences. We are embodied and an AI isn't, and that's often an interesting division in the creativity that emerges. But some of them really stimulated the trombonist. Oh, that's interesting. Could I do that? And he started to be able to make new sounds proposed by the artificial intelligence, which had learned on his sound world. So I think music is very exciting. What about the written word? You see, I thought originally the written word, there's so much data around that surely that should be the first thing for AI to be really good at. But when I first wrote this book, it was actually the thing it was worst at. I think ChatGPT has really changed that around, and we've just seen just how powerful it is. I think AI has always been quite good on short form kind of writing, so short journalism, or in fact, one of the very first written projects was up in Manchester with the Turing's team at the Manchester Universal Computer, when the computer started writing love letters to the team, and these printouts would start appearing, and people were a bit freaked out by it, but then somebody realized, oh, somebody just programmed a template, and they were using a random number generator that Turing had created to fill the template with words of passion and love. So actually one of the first computers was writing letters to the team. But I think poetry is actually a place where AI can get away with quite a lot, because poetry is quite gnomic. We put a lot of our own kind of ideas into it. So I've got a few challenges for you. So I've got 3 poems, and I'm going to ask you which one you think are artificial or not. Okay? So we're going to play bot or not. Okay? So here's your first poem. I'll just read the first 4 lines. So, mortal my mate, bearing my rock a heart, warm beat with cold beat company. Shall I earlier or you fail at our force and lie the ruins of rifled once a world of art? So votes, who thinks that is written by artificial intelligence? Put your hand up if you think. Quite a lot of you going for the AI. Who thinks that's human? That's a human. 1. Okay. You've got to commit. Come on, all of those are going, I'm not sure. Just commit. Go on. Yeah. I did before, so you're going, oh, no, I'm going to hide with it. No, this time you got to commit. So anyway, it looked like you were all going for AI for that one. Okay, here's your next one, bot or not. Right, okay, this one's quite hard to read. There are small indices of plasticide reaction of real time, of packs, of displaced exclusionary hurt, of powerlessness, magazine-fired, non-dignified as hit fatty implied internalized violence, of frozen helplessness, of off-white so who thinks that is by artificial intelligence? A few people, yes, but hey, that looks far too much like code, and he's doing a double think and saying, yeah, come on, he's not going to put that up, and it's like 2 of you. So who thinks it's human? Yeah, so most people are like, it's a bluff, but could be a double bluff. Okay, well, we'll reveal. So you've gone robot, human. So what about this last one, bot or not? Imagine now the dark smoke, awakened to fly all these years to another day. Notions of tangled trees, the other side of water. I see it is already here. Sequences of her face, see it is shared, and old friends pass their dreams. AI? Votes for AI. Yeah, could be. Votes for human? Few human. It's the most understandable of all of these. So it's probably AI. Okay, let's so you went, you went AI, human, AI. So unfortunately, Gerald Manley Hopkins is turning in his grave. That you think his poem is written by AI. That first poem was Gerald Manley Hopkins. But I chose him because I've never understood any poem that he's ever written. He was high on whatever. I don't know what he was high on. You were right that the second one is human. This is a young Australian poet, Mes Breeze, who is very interested in the idea that code is kind of like a bit of poetry, and this interface between our sort of poetry and computer poetry. So that's actually 2 humans. So you were right. The last one was too good in a way. It was Ray Kurzweil had a kind of fusion of Victorian poets, and I think you can even identify the 2 poets which were merged to make that poem. So poetry is kind of easy and short form, but what about sort of longer form? What about the AI's novel? When are we going to get AI's novel? I mean, some people have already tried to get AI to write something more long form, a novel. There was a group in America called Nick, who were kind of like a collective of artists and engineers, and they were big Harry Potter fans, and they were very disappointed there were only 7 volumes of Harry Potter, and they said, well, why don't we get AI? There's a huge amount of data there, just churn it in, get it to make another volume of Harry Potter for us. So they did this, and it started off pretty well. I actually love the title, Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. It started off pretty well. Magic. It was something that Harry Potter thought was very good. So, right, it's got magic as a major theme in these books. Leathery sheets of rain lashed at Harry's ghost as he walked across the grounds towards the castle. I love that image. Leathery sheets of rain. I wouldn't have come up with that. It's a very creative kind of image, but you can feel it, you know, the leathery sheets of rain. Pretty good start, but from that point it started to lose the plots quite literally. Ron was standing there and doing a kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Ron's shirt was just as bad as Ron himself. So I think J.K. Rowling is pretty safe. But actually, you know, this was pre-ChatGPT and ChatGPT-4. So how good is GP? You know, it's pretty good now. It has a pretty long-term memory. So I think it can do about, you know, it can sustain a conversation of about 20,000 words, and it will know what's been said and refer back to that. So 20,000 words is beginning to get beyond these sort of short-form things. There was a very interesting novel written by an artist. Well, it was GPT-2, I think, which is a kind of to and fro between the two, and was very sort of a stream of consciousness on both sides. Well, stream of consciousness on one side, and who knows about on the other side. But it was very interesting. Actually, the AI got the ChatGPT, or GPT-2 or 3, got very obsessed with taking ayahuasca in this story, and the artist was saying, "You're not going to," but it was really interesting because it really wanted to know what it felt like, and this was the one thing, you know, as an unembodied, it was not going to be able to, but it got obsessed with that. But I have seen some interesting projects because, you know, this is a very powerful tool. It's creating things which are longer form, but I think that AI is still having a big problem with time. And, you know, narrative involves being able to hold things back. And there was an interesting project I read about where a novelist tried to write a spy novel using ChatGPT and gave it the information that was going to be part of the plot. But ChatGPT just blew the fact that this was a double agent, like in the first chapter, and that, you know, that just didn't understand that you needed suspense and hold things back. And I think, you know, still image, very good. Moving image, you know, I did a project where we tried to make a new Fellini film, a 10-minute Fellini film. It was quite fun, but again, it's sort of just, it doesn't have a good concept of time. And this also emerges in the music projects, because musically it's quite good locally. The jazz sounds pretty convincing, but as it goes on, it gets boring. It doesn't have anything to say, it just meanders, and I feel the writing is often meandering. It's pretty consistent now. It doesn't say such crazy things as this, but it still is a kind of, things are still locally making sense, and that's of course much of the AI is generated in that way. It's what's the most likely thing that's going to happen after this. I think that's why actually the game of Go is quite surprising, because that did require a temporal element. That was a very early move, which had a big implication late on in the game. So it's not like it can't do things across large swathes of time. But what about my own subject of mathematics? You know, can this actually start to do creative mathematics? Now, one of the things I said that people think that what we're doing is kind of long division to lots of decimal places. Actually, if you dig deeper, what they really think we're doing is trying to prove all the true statements of mathematics. You know, all the things that are true about numbers and geometry. And this again is a very misguided view of what mathematicians do. This is a bit like saying that you know, the maths department here, that what we're doing is like creating what Borges wrote about in the Library of Babel, a library with every single book it's possible to write. You know, that's what we're trying to do, which is of course, well, that library contains everything. But actually it contains nothing, because nobody's made any choices. The point about the Bodleian Library is there are people who make choices about which of these particular books is important. And that's actually important in the way that we create mathematics. We are making choices. This is the mathematics that I'm most proud of, a discovery of a symmetrical object in high dimensional spaces whose symmetries reflects elliptic curves, a connection that nobody thought was possible. It had that kind of emotional, what, those two are connected? I love telling the story of this thing. It's a choice I made, it's a journey, it's a story, it's a narrative. It takes you from somewhere that you thought you knew about to somewhere completely different. And I feel that that's the aspect of mathematics that AI is still going to have difficulty replicating, which is that we are storytellers. We tell stories about geometries and numbers, but the choices we make are very motivated by the kind of similar issues to narrative in writing. And so, actually there was a reference earlier on in the talks to Poincaré and about his kind of aha moment of stepping on the bus. But Poincaré also wrote very nicely about the importance of choice in doing mathematics. To create consists precisely in not making useless combinations. Creation is discernment, choice. The sterile combinations do not even present themselves to the mind of the creator. But I think we are beginning to see some interesting roles of AI in mathematics, and we've seen it here in the department where one of my colleagues, Mark Lackenby, worked with DeepMind and gave it DeepMind a huge amount of data about knot theory, and the AI was able to spot a pattern that we'd missed. And it proposed the connection between two things which you didn't realize might be connected. It was unable to write the story of the proof. But what was really exciting was, for me, AI is a little bit like Galileo getting a telescope and suddenly being able to see deeply into the solar system and see new things. We're seeing deeply into data and seeing new things using this tool. And it was able to make a conjecture that then the humans went on to actually prove. So I think, in mathematics, we're going to have a very powerful new collaborator, a telescope, to help us look deeper into data and make those conjectures, which we will then spend our time trying to create. But I think, always what motivates a mathematician is very often a kind of aesthetic sense. Weierstrass, very famous analyst, wrote, "A mathematician who is not at the same time something of a poet will never be a full mathematician." Now, going back to, I think this idea of consciousness and creativity emerging at the same time is actually very important in trying to understand a question which came up in the previous talk about whether AI might ever be regarded as conscious. I like this as a starting definition of Margaret Boden's, but actually the definition I sort of came to really love towards the end of writing my book was one actually by psychologist Carl Rogers, who he said it's towards a theory of creativity. He writes that it's an urge to expand, extend, develop, mature, the tendency to express and activate all the capacities of the organism to the extent that such activation enhances the organism or the self. So it's an exploration of our own conscious world. But I think it's also an extension of just trying to see whether something I produce makes you see in a different way, or that we are able to sort of share a story or share music and actually understand that we are having a common experience. I think that the role of creativity as a probe to working out whether something's conscious or not, and whether consciousness is similar across a species or across other species, is going to play an important role in the hard problem of consciousness. That if you want to know whether something is conscious, I think we're going to have to face the fact that at some point we're going to have to know whether the computer, and we've already seen, there was a slide put up in the previous talk about the Google employee who thought his large language model was conscious, and we all kind of laughed at it. But actually, I think it raises already a significant problem that we're going to face. When are we going to be able to say that it's passing this test? And I think actually when it writes its novel will be the moment, in a way. Its creativity is going to give us a real insight into whether something's going on. Because the one thing that's missing at the moment in all of this AI creativity is the word intention. There's no intention coming from the machine. The intention is always coming from us. Intentionality, I think, is an important distinction. But when it has a conscious, it probably will have intention. It will be burning to tell us what it's like to be a machine. George Eliot wrote, the role of art. The greatest benefit we owe to the artist, whether painter, poet, or novelist, is the extension of our sympathies. The extension of our sympathies. Art is the nearest thing to life. It is a mode of amplifying experience and extending our contact with our fellow men beyond the bounds of our personal lot. And so I think that will be our helpful tool in understanding if a machine ever became conscious. I'm going to skip this one. But that consciousness, when it emerges, of course, is going to be very different to our own. And, as Wittgenstein very famously wrote, if a lion could speak, we're not going to be able to understand it. And we're going to need these tools of probably creativity to understand what it might feel like to be a machine. Thank you.